Alright, let's look at the error bound for Simpson's rule. Alright, so error bound for Simpson's rule, e sub s is bounded by k, which is the upper bound for the fourth derivative of f, times quantity b minus a to the fifth power over 180 n to the fourth. Right? It's a fairly complicated formula, but we can handle this. Right, so the hardest part is, I guess, finding the fourth derivative. I guess it's just a little tedious. Alright, so let's do that. So let's dive right into this the example problem number 22. Alright, so we want to use the Simpson's rule to approximate integral from 0 to 1 e to the x squared with respect to x. Alright, so obviously we have f of x sitting right here. So this is our f of x. Alright, so we're going to have to take fourth derivative. So first one, alright, derivative of x is going to be, alright, so e to the x, then by chain rule, multiply by derivative of x squared, so it's at 2x. Alright, so that's the first derivative. And the second derivative, alright, I guess I'm gonna have to use the product rule. So I'll take that as the first guy, take that as the second guy. Alright, derivative of x squared would be 2. 2x is 2. And times the second guy, e to the x squared, plus you have a 2x times derivative of e to the x squared we just did. So it's a 2x e to the x squared. Alright. So this is going to be, so I'm going to just clean this up a little bit. So you have a 2, and then you have plus 4x squared. Then I'll pull out e to the x squared. Alright, so another derivative, third derivative is going to be, right, so I guess I'm going to take that, I'm going to take this as the first guy, and this is our second guy. Right? Derivative of the first guy would be derivative of 2 is 0, derivative of 4x squared would be 8x times the second guy, so e to the x squared, plus first guy, so you just copy that, 2 plus 4x squared. And derivative of e to the x squared would be 2x e to the x squared. And by cleaning it up, we have, there's 8x here. Alright, then I'm going to pull out the e to the x squared out. Alright, then 2 times 2x is 4x, so I'm distributing 2x to 2. That would be 4x, so I'm going to combine with 8x, so I'm going to just erase that. So 8x plus 4x is 12x, plus, then distribute 2x to 4x squared, so that would be 8x cubed. Alright, we're almost there. One more derivative. So we take the fourth derivative of f. You get, alright, so first guy, this is our now first guy, this is the second guy. Alright, derivative of 12x is 12, and derivative of 8x cubed would be 24x squared. Then you have e to the x squared, plus we have 12x plus 8x cubed. Right, and the derivative of e to the x squared would be 2x e to the x squared. Alright, then we're going to clean it up. I'm going to go down here. Alright, so as usual, I'm going to pull out e to the x squared. I circle those so that I don't miss anything. Right, e to the x squared. Alright, then we have 12. Alright, so circle that. And then you have 24x squared, right? So plus 24x squared. and then I'm going to distribute 2x to 12x, right? So that's another 24x squared. So instead, I think I'm going to just write, instead, so there are 24, 24, so 48. So 48 x squared, right? Then we just have to distribute 2x to 8x cubed. So that's going to be 16x to the fourth. So plus, so 2 times 8, 16 x to the fourth. All right, so it looks like that's everyone. All right, then we want to find k. So what would be k? So we look at the largest possible value of fourth derivative. X is between 0 and 1. You know, lower limit is 0, upper limit is 1. All right, so it looks like this is just an increasing function. So the larger the x value is, the function value is going to be larger. So I'm going to put the 1, right? So this is going to be 12 plus 48 times plugging 1 plus 16 and e to the 1 again. So that's e. So that's going to be, right? So that's going to be 76 e. All right, so we got 76e, all right, for k. So this is our key k value, all right? After that, then we know what to do, right? So k value, so we look at the error bound for Simpson's rule, right? All right, k came out to be, we just found out that the 76e. All right, b is 1, a is 0, and you're raising it to the fifth power, all right, which is going to be 1 anyway, so I'm going to just scratch that out. It's going to be 1. And then you have 180 n to the fourth power. And we want this guy to be within, right, 0. Let's see, let's make sure I have the right number of zeros. 1, 2, 3, right, so 0, 0, 0, 0, 1. Right? So all we have to do is solve this inequality for n. Right? So first thing I would do is, let's see, we can simplify. Actually, I'm just gonna go ahead and take the reciprocal. All right, so you have 180 n to the fourth over 76 e. All right, and so this is this is going to be, let's see, 100,000. So reciprocal of 0.00001 is 100,000. Right. So when you take the reciprocal of both sides, we have to flip the direction of inequality. So it's going to be greater than or equal to. All right, then we can just simply multiply both sides by, let's see, I have to get rid of 76, I have to get rid of e, I have to get rid of 180, and do that. Then you get n to the fourth power is greater than or equal to, right, 76, let's see, 0, how many zeros? 5 zeros, e over 180, right? I can at least knock off one of the zeros, and we can do more, but I'm going to just go ahead and compute it. So this came out to be, right, bring out the calculator. All right, so we're going to type in 76, let's see, how many zeros? 4 zeros, 1, 2, 3, 4 zeros, and times e, so we have e here. To the first power. All right, then we're going to divide through by 18, right, because we already knock out the one of the zeros. So this came out to be, all right, that, right, then, oh, actually, I forgot to take the fourth root, so let me do that first, all right. All right, then I'm going to take the fourth root. Yeah, I realize that the number is really big. So n is greater than or equal to 4th root of 7600000 over 18. Right, so let me get that value instead. Alright, so let's see, I'm going to just erase that. Alright, the calculator. Alright, so I already have that value, so what I can probably do is parenthesis, and then I'm going to just do the answer from the before, and then raise it to the 1/4 power, which is equivalent to 4th root, and then hit enter. Alright, so this came out to be 18.4, right? And it's tempting to say that this is we want the n to be at least 19, right? Remember that the Simpsons rule only works with even n. So if it's at least 19, then it's actually at least 20, right? Alright, so that's the smallest n value that guarantees that the method with the Simpsons rule, the error is within 0.00001. Alright, that's it. I hope that this was clear.